Okay, so on this problem, we have some negative powers. And remember, negative powers need to jump right where they're at. So in other words, this is going to become 1 over 2 squared plus 1 over 3 squared, 1 over 2 squared minus 1 over 3 squared, like that. Because remember, negative powers, they're negative, they're unhappy, they're unhappy where they're at their job, so to speak. Jump to the other side of small fraction, right? They cannot then become positive. Then they're happy. So yeah, the deal is you cannot jump them down across the major bar because they don't have times there. That's the difference on that, right? Because you might think, well, don't we do like that? That one jumps up there, and then don't they do that kind of thing? Yeah, if there was times, if this was times in between, that would be exactly what we would do. So cannot with when there's adding and subtracting. We cannot jump the big bar. We cannot jump the big bar because of adding and subtracting. If it was multiplying, we totally could. So they just jump in place, so to speak, right where they're at. Then they become positive. Right? So negative powers are negative. They're unhappy where they're at. They jump right where they're at to the other side. Now what are we going to do? Well, we are gonna. This is a complex fraction now, right? Fractions over fractions. So we're going to multiply all the terms, top and bottom, by the LCD over 1. And what is the LCD? 1 of each type of term under a small bar, or repeats, take the highest power. So I look here and I've got a 2 squared, 2 squared, 3 squared, 3 squared. Now, if you want, you know what, probably you're thinking, can't we just make that? Can't we just change that to what those numbers are? Totally. Yeah, if you want to do that, it's really optional. So I'm just going to go, I'll make that 1/4, 1/9, 1/4, 1/9, right? Because 2 squared, 2 times 2 is 4, 3 squared, 2 times 3 is 9. You could do that, or you could leave it back. Like, it'll work either way. I'll just do this one now. All right, so what's the LCD gonna be? It's gonna be 4 times 9 over 1, right? You use them both. 4 times 9 over 1, 4 times 9 over 1, 4 times 9 over 1. Is that making sense? It's one of each type of term. So I don't use both the 4s. 4 times 4 is 16. I don't use both the 9s. Just use 1 4 and 1 9. One of each type, right? One of each type. And then what do we do now on step number 3? You cancel all denoms. So I'm going to go, okay, 4 cancels 4. Let me bring that down here and see what we have left. So this only leaves 9 plus. And here 9 cancels 9. That only leaves 4. On the bottom, 4 cancels 4. That only leaves 9. And here 9 cancels 9. That only leaves 4. And so what is that? 13 over 5. And we're done. Just added them on the top, subtracted them on the bottom. All right, let's recap what happened. So negative powers are negative. They're unhappy at their job. They want to jump to a new job. Then they'll be positive power, happy. But you can't go across the big bar when you have adding, subtracting. If that was times, that'd be exactly what we would do. But it's adding, subtracting, so they have to jump right where they're at. They can't cross the big bar. So they have to go underneath a 1 right where they're at. And then that's 1/4 and 1/9. And then when we got fractions over fractions, that's called a complex fraction, the way we deal with that. So we multiply all the terms top and bottom by LCD over 1, which is 1 of each type. So 4 times 9 over 1, 4 times 9 over 1, 4 times 9 over 1, 4 times 9 over 1. Then just cancel all the denoms, bring down what's left over. And there we go.